Hi, welcome back. So we are now at part 5 of the tutorial series for Proximal One, an interactive audio system for Unreal Engine. So this time we're going to have a look at Custom Metasounds. So what is the Custom Metasound option? So Proximal One can use two different audio source modes for its Metasounds. So you can either use the audio file source mode, and when it's set to that, what it's going to do is pick a Metasound based on your user configuration, and this is done for it's done for optimization, so that it will pick a Metasound that just uses the effects that you want to use rather than running every single effect. But you can also set this to Custom Metasound. So what happens when you select that to Custom Metasound, it will enable you to load in your own Metasound graph. For example, if I come down to where it says Custom Metasound, we've got an option here to set a Custom Metasound selection. So just as a quick demonstration, so this is what you would typically get when you place the audio instance into your level. So this one's set to audio file, and it's going to use the default loop. So if I just hit play, you can hear the default loop going on. Now if we were to set that to Custom Metasound and now press play, you can hear that we're using the default demo patch that's loaded into that Custom Metasound entry. So what this patch is doing is it's using an LFO to modulate the frequency of a oscillator, and the LFO frequency is being controlled by the player's proximity. So we'll just come out of that. So if I was to also change the visual component to Custom Metasound proximity, we can see that we've got our own proximity variable just for Custom Metasounds. So in the Custom Metasound section, you've got a bunch of settings that you can use to adjust that variable, so how that proximity value changes. So just quickly, if I just open up this one, we can have a quick look at it. So this is the default one that loads up. So it's just a demo sample. So it uses a bunch of the patches that come with the asset to create its sound, which means when you've got a custom Metasound with these in it, you can still use the things like the LFOs and the filters, for example. So you can combine the things that are the features in Proximal One with your own graph. So what you could do if you're creating your own graph is you could either go to the MetaSounds folder in the Proximal One folder, and in Custom Metasound you could either open up this template. Actually, I suggest making a copy of the template, don't edit the actual template. So you could either edit a copy of the template, and that would give you all the functionality because everything's pre-wired, and then you could just add the additional things that you want and remove the things that you don't. Or you could create your own Metasound graph from scratch and add in the patches and then assign the inputs, and it should work. So as an example, if we were to come to the Metasound patches folder, you've got all these different patches, and what you could do is just drag and drop them into your graph. For example, if we wanted control over the dynamics and we wanted it to work with the blueprint, once it's in the graph, you could just drag off of the inputs and then select promote to graph input. And so when you do that, it would create the right variable name, provided you don't already have it in your graph. So that would be one way of doing it, but that could also take a little while with some of the patches, because if I just delete that a sec, for example, if you look at the LFO patch, it's actually got quite a lot of inputs, especially when you see it here. This one, for example, it's got a lot because it's quite a complex patch with lots of things going on. So probably the best thing to do would be to edit the template, or a copy of the template, which reminds me, that's what I need to do now, is make a duplicate. So if you just right click on it, so we're just going to go, actually I call it tutorial. So what else have we got in the template? If you look at the top, we've got a bunch of variables that aren't actually connected to anything. And so what these are, I'll just move that out of the way a sec. In the Custom Metasound tab, when you've got your instance selected, if you scroll down, you can see that you've got a bunch of variables that correspond to the variable names in the Metasound graph. So you can use these in the editor to adjust the variables in your graph. So for example, if I was to connect user variable A up to something, then I could control it here in the editor. So what I want to do is actually demonstrate this, how we can actually modify this patch and get something to work. So also worth mentioning, so if you were to create a patch using the default instance, so you've just dropped it into the level and you've tweaked it and you've adjusted it, and you don't have it set to Custom Metasound, you're just using audio file. When you set that to Custom Metasound and you load in this template, that patch should work just the same way that you had it. There might be one little thing that's different, which is I think it's the delay placement. There's no switching for where the delay is in the graph, but I think that's it. So it should sound exactly the same. So what that means is if you've created a patch, you can load in this template, a copy of the template, and then you can edit the template and assign your own variables to it. So that's what we're going to have a go at doing. So I'm going to show you something that I've created using the default audio file mode, and I've sort of tweaked it and created a sound in the editor, and then we're going to have a look at modifying it so that we can sort of take it in a different direction. So if I just move that out of the way a sec. So if I just quickly take that demo one, I'm just going to bypass it, and then I've got one here which is bypassed at the moment. So if I uncheck that and just make sure the volume's not too loud. So if I just go into that now and hit play, we can have a listen to see what this sounds like. So you get the idea. So if I'm going to bypass that and just show you how quickly how that sound was made. So if I've got another one here, which has basically it's got all the same settings, but everything's sort of turned off, so we can hear step by step how it was put together. So if I press, let's just make sure that I've got that enabled on live editing. So if I just press play quickly. So basically it's taking one of the audio samples and it's just looping it over to start with. So if we just open that up, so it's taking that, and I hit play again. So it's basically looping that sample over, and then we're applying the LFO, LFO1. I'm going to set that back to 1. So that is using the random step to generate a pattern that modulates the pitch, and I've got the scale set to natural minor, and then it's just using a seed pattern, so seed 0 twice and then seed 2 twice for 2 bars, and re-triggered on 2 bars as well. So that creates our pitch, and then we've also got the envelope. So that's set to ADSR, and you can see it's triggering from random step LFO1, which is our pitch LFO. And then we're enabling the filters, and the filters set to proximity, and it's just filter 1 that I'm using, which is a low pass filter. And then on LFO2, if I set that to 1, we're sending, we've got a send to the filter cutoff, which is a 3 octave send, and we're using randomized LFO2 rate and a sine wave as the shape. So we're randomizing the rate, and it's a sine wave, and that's giving it that wow wow sort of sound. And then the next thing, we've got this enable gain pattern sequence, so that will sort of create some gaps in it, sort of breaks it up a little bit. And then we've also got the dynamics, the compressor. We're using upward compression because it sort of brings up the level sort of nicely, gives it a sort of more raspy sound. And then what I did is I just put a little bit of reverb into it and some delay as well. So yeah, you get the idea. So you can see how with just a few settings you can transform just like a small piece of like audio to like a melody that sounds pretty cool. So just gonna do I need to save that? Actually no, I think I'll let it reset. So what we'll do is we're gonna bypass that one again and go back to the original one. So the visualizer looks different because it was on a different setting, that's all. So I thought what we could do is we could take that current sound, how we've got it set up now, and we could change the audio source mode to Custom Metasound, load up the template graph, and once we do that, we should still have the same sort of sounding thing. So let's try that. So if I change it to Custom Metasound, and I'm gonna just change the visualizer as well. So Custom Metasound proximity. So currently this instance would be using that default patch, so I want to change that as well. So where is that? So we've got this one that I created a minute ago for the tutorial. So with that selected, just gonna load that in here, and fingers crossed it should sound the same. So if I hit play now, right, so now we've got that sounding the same, we can modify that graph and have a play around and see if we can do something different with it. So so just quickly, before I do that, it might be a good time to just explain the proximity variable and how all this works. So when you've got the visualizer set to Custom Metasound proximity, this is what's going to show. So the translucent area is going to be when the proximity variable is at its minimum, and then it sort of goes blue and then into sort of a pinky hue. So the first control we've got is increase area where the value is at the maximum. So if you do that, it's just gonna boost the value and have it clamped at the maximum value, which enables you to control the area where the value is at its maximum. So the next setting we've got is the minimum value. So the minimum and maximum by default, they're set to 0 and 1, which you might want for a lot of things, but for some things you might want higher values. For example, if you're controlling frequencies, like the audio frequency range is 20 Hertz to 20,000. So you can enter that in there if that's what you want to do. And then we've got this one, the XYZ response curve. So if I just set that one back, so that will just it'll keep the minimum and maximum values in the same place, but it will curve the response between those two values. So with it set to 1, it's going to be linear, and then you're sort of arcing it downwards or arcing it upwards depending on how you've got that set. So the next setting, we've got scale proximity logarithmically. So that's useful if you are using this to control, say, a filter cutoff. When you've got that set to logarithmic, it will split up the octaves for the frequency so that they cover an equal distance each. Without that set, they are going to change exponentially, so that might be something that you want to have ticked depending on how you're using this. I think we can probably untick it in this case. So then we've got use x-axis proximity and y and z. So what this is basically we can disable an axis that we don't want to be factored into that proximity variable. So we'll just disable the z-axis there, but we can also disable the x if we want, or we can have it on the y-axis, or we can obviously do a combination of them. So we can sort of customize how we want the variable to change. So I think we'll leave it on the x-axis for now. And then we've got a few settings here. So x-axis edge to edge. So if we tick that, you can see now it fades from one end to the other instead of into the middle. And we've got one here that allows us to invert the direction. So so we did want the y-axis in it as well. We could sort of customize how the two are combined together. So for example, now we're seeing that it will fade into a corner. So if I just take the y off for a moment, and yeah, keep it set like that. I think that's how we're going to use it. So this variable that it outputs in the MetaSound template is this one here, player distance sum. So when you've got that connected to something in your graph, then the proximity based on this visualizer is going to affect that variable. But we've also got player distance x, y and z. So what that is basically it's the single axis or axes for each before they're calculated to give that variable. So you've actually got them individual as well if you wanted that for any reason. For example, you might want to apply an effect that just occurs on the y-axis and a different effect that occurs on the x-axis. So by having them separate as well, you've got that that ability to do that. Then we've got one here that says player speed. So we just look in here, right down the bottom we've got this option, calculate player speed. So the blueprint will get the player's speed and will send it into the MetaSound graph, and you would have to enter in the player's top speed, and you can get that from your player's blueprint. And so what else have we got? We've got a tempo variable that you can use. We've got 6 user variables. We've got which are floats. We've got 2 of these Boolean variables, and then we've got a scale array. So what the scale array does is back in the editor you can select a scale that you want to use. So anytime that you've got an input variable on a node in your MetaSound graph that takes in semitones, you can use the scale array. So if you use a node like get random node, you'll be able to plug in the scale array into it, and it will pick out tuning values based on the scale that you've selected in the editor. Okay, so with that out of the way, what I thought it might be quite interesting to do is swap out the wave player for an oscillator and see if we can actually sort of turn it into a synthesizer. So the best one that I found to use, if you right click in the graph and look for just type in oscillator, and we've got this one, super oscillator stereo. So if we select that, and now I'm going to want to reroute it into our graph somehow. So what we can do is if we search for crossfade, and it gives us this node. I'm going to duplicate it over because we've got two tracks, our left and right track. So I'm going to connect that into there, and that one into there, and then this one into there, this one into there, and then we're going to route it where we had it before. And then we can just copy that user variable. So we can use user variable A to select whether we want the wave player or this oscillator. And then if we were to, because we're using LFO1 to control the pitch, if you look at the detune input, the comment says max pitch offset for any oscillators in semitones. Well, we know that our array sends out semitones, and because I'm using the same array in the LFO patch, so what we could do is we can take the signal from that and plug it into our detune, and let's just save that now. And if we were to press play now, what we would hear straight away would be the patch as it was originally, because of the crossfade node this node hasn't yet been changed to use input 1. But if we were to change this user variable A, this one, to a 1, then we should hear the result of that oscillator. So actually, it's just one other thing I want to do quickly is just change that to a saw wave, because the sine wave might not be as clear when you hear it. So we just save that again. So I'm just gonna hit play. So change that to 1. So we can hear now it's using the oscillator that we put in. And actually I'm going to turn the filter off because that's going to be distracting. So I might just quickly change the envelope as well. So what else can we do with this? So what I thought might be quite interesting is if we added some FM modulation to it. So I'm just going to stop that a moment. So the way to get FM to work in the MetaSound graph, the modulation pin takes an audio signal, but you can actually convert a float into an audio signal. So we could use the LFO node to create a float value, which will give us a nice clean modulation. So if we right click and search for LFO, we could use the output from here, but we've got two LFOs and one of them's controlling pitch and the other one is assigned to filters, even though we turned it off at the moment, but we're going to use it again. So I'm just going to add a new node, and that's the beauty of this custom Metasound method, is we can just expand it and add additional things. So what we would do is we would pull off of the output pin, and then we type in float to, and we want to search for float to audio, and that converts it to the type of signal that we want. There is one other thing that actually I want to do, is just add a multiply node to that before connecting it, and then I connect that to modulation, and then I'm going to use another one of these user variables, so I'm just going to copy that one. So user variable B, I'm going to use that to control the amount of that modulation in terms of depth. And we're also going to want something that we can use to control the frequency. So to start off with, I'm going to use another user variable, but we'll change that in a moment once we've figured out what values we're going to use. So we just connect that into there. So let's have a listen to it now. If I just save that. So if I just come into here and make sure I've got the right one selected. So in Custom Metasound, we've got our user variable B, that was our LFO depth. So if I just change that to 1, and we've got our value C, which was our frequency. So maybe increase the depth. And maybe around about 30. You can hear that modulation is having an effect on the oscillator now. So I'm just trying to figure out a range for it. So I kind of like from 0 to 35. So if I just save that now, and what we can do, just stop that. So instead of using this user variable, I'm going to come up and grab the player distance, or make a copy of it, and just connect that in its place and save that. Now up at the top where we've got our minimum and maximum value, I'm just going to set our maximum value to 35. So now we should be getting the proximity controlling that variable. So let's have a look at that. So you can see how we can take the sounds that we've created just using the editor and just turn them into something else. So we could take that one step further. We could add in another oscillator maybe, and we could also layer it back in with the original sound. So actually that would be quite easy to do right now because we've got a variable set for that. So let's just have a quick look and see what that does. So where's it gone? Custom Metasound. So it was our user variable A, so let's just hit play. So yeah, was to change that to a value that would allow it to be mixed in. So here we're getting sort of both the wave player and the oscillator now both at once, and we can also enable that filter. So just enable the filters again. That sort of help merge it together a little bit better. But yeah, I mean that's just I wouldn't say it's a great sounding patch, but it gives you an idea of what you can do. So if I just come out of that now. Yeah, so I think that kind of wraps that up now. So if you've got any questions, just drop them in the comments and I'll do my best to try and answer. So just quickly before I end this video, I just want to make clear that you can actually load in any MetaSound that you've created and use the trigger system for Proximal One with that MetaSound. You don't actually have to use any of the patches or wire anything up. So that just depends if you want to use the additional features from Proximal One, like the filters and the LFOs, for example, but you don't need to actually do that. So to get your own MetaSound graph to work with this system so that the trigger system works with it, there's just a couple of things that you need to do. You just need to make sure that you've got the on-play input connected to trigger the MetaSound, and you also need the on finished connected as well, because that will enable the stop trigger. Okay, so yeah, I thought I'd just throw that in quickly just in case anyone was unclear about that. So yeah, I think that wraps it up for this video. So in the next video we're going to be having a look at the filter system and how that works. So hopefully I'll catch you with the next video. Cheers and thanks for watching.